Hello everyone. My name is Evan Yu, and I'm here to talk about Vite and the future of JavaScript tooling. Okay, many of you have probably heard of Vite, and so in the past few years, it's been growing really fast, and we're now seeing 29 million weekly npm downloads, more than 1.1 thousand GitHub contributors. And we have a vast ecosystem of tools and frameworks building on top of Vite, including probably some of the most familiar tools that you've been using. And we have companies using Vite or Vite-based frameworks in production, including some of the biggest names that we have heard about. And today, I believe it is no longer an exaggeration to say that Vite has become the shared infrastructure layer for the next generation of web applications. That's a lot of responsibility too. So we've been always thinking about what we can do to make Vite serve this role better, right? And we came to the conclusion that Vite is far from perfect in its current state. So we've been hard at work in finding what we can do to improve it from the ground up. The biggest problem that we saw previously was that Vite still relies on different dependencies with overlapping duties. Vite, as a high-level tool, wraps a bunch of third-party dependencies, including ESBuild, rollup, and sometimes users also rely on SWC for transformation. So the problem with this is that many of these tools have overlapping duties. They're written in different languages. There's a lot of efficiency problems when you pass data back and forth between these tools, and they all have slightly different behavior when it comes to bundling or transformation. So we decided to build a bundler by ourselves to solve this problem. We're building a bundler called Roldown that is designed specifically for Vite to serve its goals, right? But as we are looking into the work on Roldown, we started digging deeper into the stack. We realized in order to build a bundler, we need to also pick and choose what parser we use, what AST we use, what transformer we use, what minifier we use. And when you go down the rabbit hole, you realize the challenge that Vite is facing is really a reflection of the JavaScript ecosystem at large, right? So if we peek into the bundler and look at all the lower level dependencies that a bundler needs, we realize that the JS ecosystem actually suffers from fragmentation at every layer. So for parsers, transformers, test runners, linters, formatters, all the things that we use at every layer for every task, there are so many different solutions. And it just leads to a lot of decision fatigue. And for the average user who are just getting into JavaScript development, it's probably not the easiest task to decide which one to use. So this is not all bad, right? The JavaScript ecosystem was probably one of the most vibrant ones, the most active ones. And this sort of lack of central guidance results in the freedom to explore, and the abundance of choice was critical for the ecosystem in the early days. These solutions are what helped us to get where we are. We're building more ambitious JavaScript apps than ever before, and these are the tools that helped us get here. But as the language matures, as we arrive on a lot more consensus and conventions on some of these problems, this has led to a complexity tax for everyone, right? So I believe it is now a time where JavaScript deserves a unified toolchain. So we've been hard at work on this goal at VoidZero, which is a company I have founded. And the mission of the company is really to build a unified JavaScript toolchain to give users a more coherent stack, a coherent experience when we want to just get into it and stop thinking about pick and choosing a bunch of different solutions. So there are 4 major open source pieces that the company works on, including Vite, Vitest, Roldown, and OXC. And here is a more detailed overview of the stack. So at the very top are the framework tools that builds on top of the Vite ecosystem. Vite itself is obviously the integration point. Many of these frameworks also use VTest. VTest can be used alone in any JavaScript project, really. You can use it to test backend code. Many projects that's not even using Vite would also use VTest. So Vite and VTest interops more directly with frameworks and end users, right? And Roldown is the bundler that supports Vite internally. It handles some of the more low-level tasks of bundling your code, optimizing your code, and give you advanced chunk splitting, etc. And at the bottom layer, OXC is the language toolchain that supports all of the higher level pieces. So OXC itself includes the parser, which is at the core. So the parser also defines the AST that we use for all these other tasks, such as transformation, linting, formatting, minification, semantic analysis, etc. OXC also ships a resolver that is Node.js compliant. The minifier currently is in alpha status. It is already usable, and the formatter is still work in progress. So by combining all of these pieces together, we also are working on a solution called VitePlus. So VitePlus is meant to be the end-to-end toolchain that integrates all of these things together in a more coherent package. So one side question, why Rust, right? So if I haven't mentioned it before, everything in these in the lower level pieces, both OXC and Rolldown are written in Rust. So we picked Rust because it provides a good balance between performance ceiling and memory safety, right? And more importantly, it already has a very active ecosystem around JS tooling. So it is easier to find libraries and contributors. It has very mature JavaScript interop, right, through the excellent NotPIS project. And it also has very mature WebAssembly support, which allows us to, for example, compile Roldown into WebAssembly and run directly in the browser with great performance. So an important note is we're not trying to Rustify everything, right? We believe that there is a good abstraction layer where Rust is really good at for the more well-defined and perf-sensitive tasks. For example, transformation, parsing, bundling. But for the CLIs, for the high-level APIs that interface with the user, we believe it requires constant iteration and flexibility. So JavaScript/TypeScript is still the tool of choice for those layers. Okay, so digging a bit deeper into the progress so far. In OXC, we have completed the parser, the linter, resolver, transformer. The minifier is currently alpha status, but already usable. It actually has pretty decent performance characteristics. So I won't go into too much details for each individual items here, but some highlights. Most of these things that we have built are the fastest in its own category, even compared to other solutions also written in native languages. So the parser, the linter, the resolver, the transformer are all fastest in category. The minifier is second fastest, but it also has better compression ratio than the fastest solution. So it is still a very decent choice. Also, because the minifier is still in alpha, we actually have plans to further improve the compression ratio in the future. So stay tuned. Some additional transformer metrics. We focus a lot on the optimizing the memory usage and binary size too. So it also shows great performance in these areas compared to other solutions. And now on to Roldown. So we have been working on Roldown for almost a year and a half now, and Roldown is now in 1.0 beta status, which means you can already use it almost as a drop-in replacement of Rollup, and you'll see great performance improvements. We have completed not just basic bundling, but also integrating OXC, which means Roldown comes with built-in transforms for TypeScript, JSX, comes with built-in common JS transformations, comes with built-in node-compatible resolution, which means you don't need plugins for that. So this is much bigger in scope compared to Rollup, where a lot of these features require external plugin support. We also complete a lot of advanced features in the bundler, including tree shaking, define inject. These are features presenting ES build, but not rollup. And then advanced chunk splitting, which is something a lot of people like in Webpack, but it's not present in ES build or rollup. This is indeed implemented in Roldown. We also implement module federation support as well. We have also invested a lot of effort into behavior alignment with ES build and rollup. We actually run Roldown against ES build and rollup's test cases to get as much coverage as where applicable. And we also support rollup plugins out of the box. We actually have a 90% rollup plugin interface compatibility, and the absolute majority of rollup plugins will be able to just work inside Roldown. So, which means it's a Rust bundler, but it does support JavaScript plugins. So Roldown is currently already in 1.0 beta, and you can try it out if you have anything that's using rollup currently. And of course, the most important thing that we're working on right now is integrating Roldown into Vite itself. Before we dig into that, just some brief numbers when we compare the performance numbers for Roldown compared to ES build and other bundlers written in Rust, right? So Roldown is, as far as we know, the fastest bundler that we can think of, and it's even faster than ES build, depending on the number of cores on your machine. So the progress for Roldown integration in Vite, this is probably most Vite users right now care the most about. So this is Vite before Roldown. We have a pretty chunky JavaScript core that includes the dev server, plugin container, environment API, etc. And we rely on external dependencies such as ES build, rollup, and SWC through plugins for some of the heavy lifting. With Roldown integration, this is what we have pretty much completed at this stage, is swapping out ES build, rollup, and SWC all with Roldown itself. So this means now it's a vertical stack that is Roldown is specifically designed for Vite, which means we can ship more dedicated optimizations to cater to Vite's needs. So in a future release, which is also currently work in progress, we will also ship a version of Vite that provides an opt-in full bundle mode. Many of you probably know that Vite's dev server uses unbundled ESM. It makes things super easy and flexible. It makes hot module replacement easy to implement, but at the same time, it does introduce some performance bottlenecks when you have a really, really large app that you need to load thousands of modules up front. The unbundled approach actually creates a network bottleneck that makes the server startup quite slow. So full bundle mode is specifically designed to solve that problem. So the initial design for full bundle mode is targeting large single-page applications that are dealing with dev server startup page load problems. So phase 1 is in fact already available. We will soon, by the time you see this talk, we probably have already announced the official release of the Roldown Vite. But we have, before the announcement, we actually have been working with some early adopters, and here are some numbers that we see. So notably, adopting Roldown Vite is extremely easy because it requires no code changes. It is a drop-in replacement. So we have seen projects like Excalijaw switching to Roldown Vite and get a 16 times faster build by simply swapping out the npm package. So no code changes, no config changes, really. It just gets 16 times faster. And depending on how your project is configured and depending on the number of custom plugins you use, you will see varying levels of performance gains. But at the minimum, you should see like 2 to 3x faster builds. These are probably the most complicated applications with tons of custom plugins. But if you are building, for example, a pure React app, you'll likely see more than 10 times faster builds. So now let's dig a bit into VitePlus. We mentioned this a bit earlier, and we're still actively working on this. This is in very, very early stages, so I'm mostly talking about something that's going to come out in the future, but I want to give everyone a sort of sneak peek and understanding what we're building towards. The idea of VitePlus is what we want to build conceptually cargo for JavaScript. If you have worked with Rust, you probably know that cargo is the all-in-one toolchain that can serve most of the development workflow needs during your Rust development. There's nothing like that in JavaScript, and VitePlus is exactly what we're trying to build to fulfill that role. So interestingly, we want to design VitePlus as a drop-in upgrade of the existing Vite, which means if you are using Vite directly today, upgrading to VitePlus means you also just use your package manager to alias Vite to VitePlus, and you're good to go. Everything will work. Everything that works in today's Vite will continue to work exactly the same way, but the Vite command line just becomes more powerful. Now it comes equipped with additional commands like Vite lib that is dedicated for library bundling, Vite test and bench, Vite linked and format, Vite new for project scaffolding, Vite task for monorepo task orchestration and build caching. It comes with a GUI dev tools, comes with workspace audits and policy enforcements for enterprise users, and will also likely ship AI integration with the built-in MCP server. So I want to dig a bit deeper into some of these commands that I talked about, right? So, for example, Vite lib. Library bundling is an interesting topic because Vite currently ships with a Vite library mode, which not many people actually use it because we have sort of held back in investing into the command due to library bundling actually being quite a complicated topic in itself. The behavior is quite different from bundling applications. That's why it needs a dedicated command or a mode to handle it. So we recently we recently moved TS Down, a project by Kevin Den, into the scope of VoidZero and the Roldown organization. So TS Down is now the official library bundler based on Roldown, and it is also the successor to TS Up, which is a wildly popular library bundler, which is now no longer active maintained. So the interesting thing that TS Down does is it comes with built-in TypeScript DTS generation and bundling, right? So there are two important things here. One is you can enable isolated declarations in your TS config to let OXC generate your individual DTS files without going through TSC. This makes the DTS generation process a pure syntactical transform, which is orders of magnitude faster than generating it through TSC. Second is we also implemented and shipped a plugin called Roldown Plugin DTS that uses some custom techniques to be able to bundle your DTS into a single file so that it not only reduces your package distribution size, but also makes the consumer of your package being able to type check your library faster because TypeScript works better when it has fewer files to work with. So it also handles a lot of conventions like multiple output formats, exports conditions, package manifest correctness linting, etc. And this will be integrated into VitePlus as its library mode. A bit about testing, right? So Vite test is going to essentially be the Vite test command in VitePlus. Vite test now is probably the most feature-complete JavaScript test runner. Initially, VTest was born as a sort of replica of Jest with the same API, but designed for Vite. But now it comes with a lot more. So it comes with browser mode, component testing, and even benchmarking features. One important thing I want to mention here is when we are evaluating test runner speed, there are some test runners, for example, Buns test runner by default runs the commands, runs each test without isolation. So a lot of these tests actually share global state, which means it's not technically safe. So if a test mutates global state, it can actually impact the results of other tests. VTest opts to be safe by default. So all the test cases are isolated, forced to be isolated by default, which makes things, there is a performance overhead for this, but we opt for correctness over performance in this case. You can disable it if you want, but we recommend turning isolation on. Linting and formatting. So OXLint handles the syntactic linting and is 100 times faster than ESLint. The rules are not as complete, and we're currently working on a JavaScript plugin system for OXLint, so you can write custom plugins for OXLint. and potentially be compatible with some popular ESLint plugins. But in OXLink itself, we have already ported majority of the rules in some of the most popular plugins. Another important topic that we're researching right now is type-aware linting. There are multiple ways to do this. There are different projects, for example, Biome exploring different directions, but our current short-term approach is likely going to integrate TSS-lint into together with OXLink to serve as the lint command in VitePlus. So TSS-lint actually integrates TSE type check paths to implement linting rules during the type check. So you only pay the TSE cost once instead of running it again in your linter. We are also actively looking at the TS Go implementation and checking out how we can implement an efficient Go Rust interop, probably using sync RPC, so that we can hook into TS Go diagnostics in our linting to perform the type-aware linting with the best performance. And then there's stylistic rules and formatting, which is currently in the works. That's going to go into the formatting. And VitePlus is going to be monorepo aware, which means we will have pipelines, build orchestration, caching similar to that of Turbo Repo, and we'll have first-class concept workspaces and policy enforcements. There's also going to be a very good GUI DevTools. If you've used Nux, you've probably seen Nux DevTools, which is made by the prolific Anthony Fu, who is now working on the DevTools for VitePlus. And then there's the single source of truth config that is shared across the entire repo for all your commands. So module resolution, transforms, respecting TS config, they should all work consistently and the same across all these commands. And finally, you want to position VitePlus as a framework for frameworks. So if you're active in the meta framework space, you'll see that there are many frameworks now going with the framework as a Vite plugin route. So Remix React Router, 10-Stack Start, Redwood SDK are all going towards this direction. And it's a very smart way of leveraging Vite and the future features in VitePlus as well. Because in the future, when you ship your framework as a VitePlus plugin, you'll be also able to hook into these additional commands. So you can do things like inject linked rules, inject custom test matchers and environments, inject DevTools panels. The possibility is limitless when you have the full toolchain accessible through the plugin interface. That said, VitePlus is still a work in progress. We're in the very early stages of it. So if you're interested and have feedback, please holla at VoidZero.dev hello, and we're eager to hear your feedback. Thank you.